How's it going, everyone? Welcome. Javier Gonzalez here. This is a continuation or the following up of the React hook, particularly on the previous video. I took some notes and described is how do we get here with React by getting to the origins and what is the problem that React solved and who actually developed this tool, which was a bunch of very smart folks at Facebook when they have this particular problem where if you have some piece of information that is shared across different UI and all of those are related somehow, you need to find some way to centralize this, right? And that's why they create now this experimental tool known as React, where they say, hey, let's now make this tool that allows to centralize all of the states in one place. And any time that a particular UI needs a fresh version of these states, we're just going to propagate those states across all of these different user interface. And then I went through describe the more technical aspect of React. For example, what React is doing behind the scenes anytime that you create now an HTML elements. You also can create your own HTML elements or custom elements. And what are the most common tasks that we have to do as someone that develop user interfaces? So from HTML and CSS and JavaScript, you just use those, right? But in the case of React, because the idea is to solve that particular problem, is now say, hey, how do we organize our applications? Because it's not about HTML and CSS and JavaScript only. It's now this layer on top of the HTML and CSS that now we are building this kind of application. So this is one. And also because at the end of the day in React you are just describing is this HTML element, but using now JavaScript functions using the create element specifically from React. So what's happening here is that becomes very tedious to do. So it's very monotonous because anytime that you have to create a HTML element, well, it turns out that you have to call that function, so on and so forth, the React create element. So, and not only that, if you want to add now logic to, because you might want to describe some behaviors of a particular user interface, right? So for example, it's like, hey, I have a collections of rated buttons or checkboxes, and I just want to get one of this value from the user, just to mention one simple example, right? And then to make our life much more easy, the React team actually say, hey, this is the task that we always have to do. So let's going to create now a language or a markdown language that allows to make our life much more easy, but introduce now complexity. Why is this? Because now you have to not only learn about this GSX and how, so what is the anatomy of the GSX? How is different from HTML or from template engines language? And what is the value of GSX? But also is that you need to have now somebody to translate that into real JavaScript or something that the browsers can understand, right? So because of this, right, is that we have to have, or we need to have is a build step. So this is the thing that say, hey, now we have to organize our applications in a different way without HTML, CSS, and JavaScript only. So this is when you introduce this kind of complexity, there is a trade-off. So the trade-off is now how do you organize your project, and also I look at how React applications organize that. So you have now your entry point, which is the index.js, and then you also have is the app home, which is the app.gsx or tsx. And then you define now your user interface plus the logic, the business logic, and in each one of those ES models or JavaScript files, right? So this is the project overview on how do you organize your project, and then we started to develop to see how you develop your applications. You use now is this particularly way to do that, which is describing as functions, right? So now because you're describing functions as user interface, and any time that React now call these functions for you, it create now a JSON that describe is the desired state of this UI. So this is one example of describing user interface and what happened when you describe those UI. And it also when you, for example, needs to do common tasks like rendering a list of elements, or a form, or a conditionally rendering elements, right? I also look at how to do that in the previous video. And when you want to provide style or styling to your components, so this is just the basic stuff that we most of the time do when we are developing user interface, right? So also on the model 2 is, well, how can we now is response to user events, right? And how HTML, CSS, and JavaScript does when listening to an event using the add event listen, or when passing is a function called directly to that HTML element. And in the case of React, it's going to call our function for us. So this is pretty much the things that we have to do in any web application, right? So you define your structure, the styling, and the behavior with JavaScript, and then you listen for events to respond to that and provide some user interactions or some feedback to the user, right? So, but what happened? But React or the developers, because now they want to solve this specific problem, which is I have some piece of information that I want to sync across all the different UIs. This is when they provide now the thing called hooks, right? Where, in other words, it's just a way to the React team provide functionality or behavior to developers, right? And this is or the common one is the user state, right? So I also look at what the user state does, or loop, the difference between rendering and paintings, and how all of this state updates happens asynchronously, why all the dance, you know. And then look at how you can, well, define now forms, how you can capture user inputs on form. What is the React way of doing that? And as you develop your application with all of this state, this piece of information, first it is important to know where you put your where you put that state, known as the lifting state up. And when you're working with complex states, not primitive but also object, right? Functions an object, arrays, map, set objects. Well, it is always important to create a new object from that, or create a new state out of that. The reasons go beyond the scope of today's video, but again, all of this is just to describe is what are the basic stuff that we as developers, front-end developers, have to do, right? And when it comes to rendering list of elements, for example, or defining small user interfaces, so for example, like inputs, right? So input checkboxes, radios, input text, input text, select text area, password. So in all of those cases, how convenient it is for us to capture that using this behavior that React give us, like the user state, right? Or you can rely on how the browsers works in that. When you're filling a form by using the submit, well, a lot of the time that actually might work for our case. If you use now a state, well, unfortunately, that's going to trigger now a re-render anytime that state updates. Perhaps this is the desired feature that you want in your app or not, right? So, but in any case, this is describing is the most common task that we have to do. Rendering a list of elements, and in that case, React needs to know which elements or to uniquely identify those elements. And the way to do that is by first, or you define a unique identifier at the database, or you create your own unique identifier using the crypto.get-random UID, right? Dynamically generate that. And there is some utilities that help us to render as collection of elements. For example, using the range function, all right? Or can go with the existing methods that the existing building objects that comes in JavaScript is the array to generate to dynamically generate elements and help you with that. Another thing is, well, forms. In the case of forms, how you work with complex forms, right? So for example, if you want to capture is different inputs, for example, is radio buttons, checkboxes, or input text, or email or password, or email, password, email, password, text, and select, and how all of those works. For example, HTML and CSS, JavaScript, right? So how you can capture that in vanilla web, and then how you can capture that in React applications, all right? And then how you can conditionally rendering elements, right? So actually, this is the daily task that software developers that work on the front end actually have to do, right? It's like, hey, do you know how to rendering a list of elements? Do you know how you conditionally render one element or not, or how to hide that? Right? Do you know how to provide style to your components? And do you know how to capture data from a form, right? And the different most common inputs on top of that, right? So because this idea on the web was so powerful, they also migrate that to mobile development. This is why we have, for example, React Native. I have experience working on those code bases. So because as you start to create now more complex applications, and I want to jump straight forward to what I really care in today's video, which is exploring now the data fetching and the memorization, is that when you have when you're going to build products, which is one of the reasons why you're getting paid for as a software developer, is that, hey, good that you know how to conditionally rendering elements, styling components, rendering lists, and and designs and capture data from a form. Good. So now let's going to build something that is actually useful. All right, and that is whether it's basic applications like blog or a landing page, or when it doesn't require too much states, right? Or heavy client applications like games or some heavy interactions applications, right? Or a SaaS, okay, service software as a service, or a back office, which it fails in the same bucket, right? So in each one of those products, for single applications, you might only want, or you just only have one single state there. But if for heavy client applications like game or something that requires to keep track of a lot of data from the browser, so you might want to consider to go with some state level management application, right? For example, like Redux or Substance, right? They are candidates to say, hey, these kind of applications, they are very good at what they're doing, or these kind of tools, they're very good at what they're doing, which is offer us a way to manage app level state data and then only update those components that update that state, right? And the subsequent components. And the other is now, if you're developing now SaaS applications, right? Software as a service, back office, that kind of stuff. So where now the state, the information, now live on the server, right? So anytime that you log into a particular app, right? So now that state or the information live on a somewhere else computers, particularly the database. Okay, so this database app that live on a physical computer is storing your, for example, credentials, right? And anytime that you want to log in here to, for example, see your bank account, right, or your social profile, whether it's on Instagram, Facebook, TikTok, huge universe now on all of these social media, all right? Or if you want to buy something like an e-commerce, right? So all of this service or software as a service, and I think this is important to recap, even though this application like here is a software as a service, like this course, because, well, they give it to me is some knowledge that I can recap, practice, and understand, because now I can apply it and solve somebody else's problems, right, in the most time efficient way possible, so I can dominate this thing. So why am I mentioning that, right? Because this software as a service, where you sign in here, you pay the subscription models to actually get some value out of this, like learning about how this tool works from somebody that has experience on the field. For example, Josh Comeda, software engineer that previously worked at Khan Academy and then at Gatsby. Khan Academy was one of the first large companies to use React at production, right? So, well, you want that kind of experience. You want that attitude and intention, and perspective that developer learned over the couple years, right? Which is here. So in any case, so now this piece of information that live on the server, right? And if you're building user applications with React user interface, now there's some couple issues here. Like first, where is so since the state of our applications now live on the server, all right? How can we now make that state always updated so it doesn't grow stale in our application? Also, how can we avoid hammering the API, all right, by catching the response? And how we can now make some paginations so we don't overwhelm the users and the browser with all of this with all of this information, and how you can now cancel data on the fly, all right, and in all of this kind of problems that are now specific for this SaaS application, there is now some companies like Vercel, for example, or some libraries that actually solve this kind of behaviors, right? Like SWR, sorry, which now something called as hooks, right? And there is another notion. This is go beyond the scope of product maintenance and product. Go beyond the scope of. Sorry. This is more a technical aspect that I'm going to describe here, in terms of understanding the difference between rendering and component things, right? So, so with that, right, that was the huge overview of what React allows us to do as a front-end developer, right? So when you want to add now behaviors or business logic to your applications, because the component is the only tool that we have, well, we overuse that. And the React teams saw that that was a particular problem, so they create now these hooks, right? So hooks are just behaviors that the React team offers to solve specific problems. So for example, useRef or useID. So useID, if for example, if you have now forms, several forms in your applications, and some of them has, let's say, is radio buttons, radio group buttons, all right? You want to uniquely identify those radio buttons. Why? Because the browser, when you define several radio buttons, okay, well, it needs some identifier. When you put now the attribute name, you need to globally identify those to say, hey, this group of radio buttons in my applications belongs to this form, and so on and so forth. And this is just to describe one of the useful cases of using useID, right? And the other is useRef. So anytime that you need to get an element from the DOM, right? So for example, to when your components renders, when a focus is the input, for example, or when your components render, you wanna now paint some, let's say, some graphic, right? Some data visualization, whether it's a line chart or bar chart, you name it, right? And this is what the mainly use case for the useRef is, right? It allows you to now hold some piece of information without triggering a re-rendering, or it doesn't participate in a re-render. So you can now access to that whenever you see fit. Okay? So this is the two most common behavior, or one of the couple behaviors that React gave us. And these hooks, they are they follow some rules, right? You must put your hooks at the top of your component and don't wrap into nested or any additional logic here. So another common hook is the useEffect. So anytime that you need to synchronize your UI with external systems, so for example, listen to global events, or for reading and writing to local storage, or for pulling data from a server, or for synchronizing with the timers, right? So for all of these cases, we use now the useEffect, which say, hey, I'm going to run is this callback function that you give it to me after every render, right? And it has, this is at the first parameter, and then the second parameter, it accepts several options. If you don't pass the second parameter, I'm going to call this callback function that you gave it to me after every render. If you pass a empty array, I'm just gonna call that only once. But if you pass now an array of dependencies, they're gonna call it when they change. And when they change, right? So now it enters into a life cycle. So because sometimes you want to, for example, listen to global events like spacebar on the keyboard, right? Yep, on the space bars on your keyboard. All right. Yeah, the space bars on your keyboard. So when that happened? So yeah, exactly. So you want to detect some global events, right? You want to detect now the space bar. Yeah, we want to detect the space bar, right? Okay. So and you want to, based on that, update now a piece of information, right? So for example, a player. Okay. So when that happened, okay, so you want to define is each one of those synchronizations per useEffect. So now, finally, what I really care about in today's video is so whenever those dependency of array change, so what happened is that this enters into a particular life cycle where it's gonna get it's going to now first, when these components mount, you're gonna call your callback function, right? And when each one of those dependency change, or when you unmount the components, well, it's going to call the cleanup function. The cleanup function is a function that you return as part of the callback function that you give it to React, right? And when that happens, for example, in the case of your or let me reparaphrase this. So this useEffect, right? The useEffect hook, you're gonna pass now a callback function, and this callback function is some statement, some instructions that you want to describe to do something, right? And those things are to synchronize the current state in your React application with some external system that I mentioned before. So reading or writing the local storage, or the timers, right? What happened when a timer's pass an X amount of time? You want to do this. I want you to update the state to this, or listen for global events. So when this thing happens, well, I want to now do that. Uh, the other is when the server give me some data, I want to update that. So all of this external system uh, that they hold some source of truth, I want to synchronize with my UI. So, because the anatomy of the use effect is that I'm going to give it to me is a callback function, right? And then also return as part of the callback function. Give me now is a another function that I'm gonna use to call that when you unmount this component, for example, or when any of the dependency change. In this particular life cycle that it enters here, it is, well, when your component is mounted, it's gonna run first the callback function. When it'll mount, it's gonna run now the cleanup function. When this component now updates any of these when any of these dependencies change, the use effect will gonna first call the cleanup function and then the callback function again, right? So this process is now involving into the topic of rendering and componenting. So why am I mentioning this? Because sometimes this is the reason why I actually hit the break here in order to move on to the other topics to finally go to the memorization is, so when I first started using computers in the late 90s, I used two different media players. So for live streaming, I had Real Player, right? So for those who are, well, if you're old enough, you might know what this is, okay? So when for live streaming, I have Real Player, right? This is a very 90 stuff thing. Real Player was okay, but it didn't really have any personality to my teenage self. There was a much cooler options available called Winamp. So this is Winamp, right? So holy moly, you know, it's like you can now tweak all the different equalizers and options, and you have now much more control of this. Between those early days and now, there have been countless media players, but there's something they all have in common. Every media player I ever used has implemented the exact same keyword shortcut. This is why I mentioned the example of the spacebar. So the spacebar key will play or pause the currently selected song. So early this morning we built a simple media player, and I think we should update it to including the spacebar shortcut. Right? Again, we're talking about a functionality, a desired functionality. All right. If you like, I encourage you to spend a couple minutes attempting this problem, but I warn you, it is surprisingly tricky. This is more like some warning things that happen in this environment here. So the whole point of this is to, when this global event happens, this is why it is important to understand what global event is, how global events works, and so forth. So when this happens, I want you to somehow capture that and then update my state, right? So in order to do that, not only to update my state, but also is to reflect that properly, right? I click on this, right? And then and two things needs to happen. So I need to update the UI, and I need to update, or I need to play the song here. The two behaviors. Okay. So, well, what I can do is to just only try to wrap this and say, well, any time that the state change, for example, like this, is playing, I think that if I do this, oh, okay, I get it. Exactly. So I have a reference, right, and I have an state. So this is the ID, this is the UI, and this is now the system for that HTML tag, right? So the play and pause, or the audio tag, the HTML element. So, okay, so I need to somehow is to synchronize this to systems to capture that. So what I can do is to say, hey, useEffect. Let me go with this. Say, hey, React. I can use this the structuring, but for this demo, I prefer to be explicit about it and say, hey, useEffect. All right, and I want to run this callback function that I'm gonna pass to you as an arrow function here, and say, hey, when you listen for this global event, Windows add event listener, all right, call key up, okay. I want you to run this functionality, right? And I want to provide now here is the name of the function here. Say is a handle handle key up, right? Handle key up, and here I'm going to receive that event, all right? And because in order to detect what the event is, I can look at the MDN, pretty straightforward, MDN docs and say event, all right? Look at the event, by the way, here, the interface, all right? The interface of the event. So for example, like the target, and from the target, the read-only target property of the event is a reference to the object onto which the event was dispatched. That's exactly what I want. So when this event is dispatched, when this event is dispatched, right? Okay, so when this event is dispatched, right? I do want to capture that, and that implement is the event interface. All right, is the target. Right. So target here, say, hey, depend of the event. Depend of the event. Depend of the event. It returns the object to which event is dispatched. So what are the events that are dispatched? In my case, is the in order to know that, well, the event was the event was okay. This was one of the events here. All right, all of these events, right? All of these events. Do you have some way to at least organize this kind of events, right? The interface events. To know more about that, or you just wrap them all of them in the event and deal with it, bro? It's just to know is a type of event. That's what I would like to know. Type, introduction to DDT mutation observers. You have is this is the interface that legacy extension, interface custom events, interface event target. Exactly, interface event target. But I'm looking for types of events that we can have. Yeah, something that helped me is what are the possible events that I can have. Introduction to DOM events. Exactly. Event listener can be removed by utilizing the remove event. But through the web platform event, some set of events, it's an object simply named event. It allows to signaling that something has occurred. Potentially a potential event target in an event, right? Can you define me is the different type of event? Event type. Okay. Okay. The type attribute must return the value it was initialized to. Okay. So what are the possible values that event type can be? Returns the type of event, click, hashtag, or submit. Yeah, that's we'd like to know. Click, hash, change, or submit. Yeah, what are the possible type that you can have, right? It's a read-only property. It is set when the event is constructed and is a name commonly used to refer to specific events such as click, load, or error. A string containing the type of event. The type of event. The type of event. The type of event. Event.type and event and log inner text. Read form DOM event type. Exactly, and event type. Yeah, but again, this is part of the spec. Spec doesn't tell any implementation. Implementation detail may vary. So, but in any case, I don't want to get loose into this. I just want to at least know what are the possible events that can happen, which is a keyword event. Okay. So when this thing happen, all right, which is the keyword, that's why I'm listening here is this on key up. Okay. So when that happen, I want you to give me now is that event, that interface, that object that represent that, and this is it, right? So So the target is the one that actually is holding that piece of information, right? When I receive this, right? So when I receive this object, if the event object from the keyboard event, the key, right? The key. Okay. So if the key, or I can use also is the code, but I think that'll be good for the key here, right? I can use the code, or I can use is the key, which is widely supported. So I'll go with key, right? If press the key, if the pressed key has printed a representation, the return value is non-empty Unicode. So you're gonna get the value here. For example, if the process key is a space key, the return value is a single space. So this might be what I want. All right. In order to detect that, I can use key, or I can use is code. Right? Limited availability. Okay. Okay. Keyword event key, as you can see here, is event key and event code. Right? So despite that this is something that has limited availability, right? Limited availability. So for example, Chrome doesn't support that, which is quite weird. Oh, Chrome in Android, in Firefox, in Opera, they don't want to support that. But in any case, I can go with this. So I can go with the code. Right? Oh, look at this, and it moved. You know, and it's detecting all of this event. And it's repainting. That's what happened. It is repainting its position. At least in this. Right? It's updating the position. So in other words, it's repainting that. Okay. So the key code here is event code. Yeah, let me take a look at this. For example, here is a space. All right. Good. Is a space. So now if the code is equal to space, right? So if the code is equal to a space, right? I do want to now is update my state. So I can say is, hey, set is playing, all right? And let's go into update the state, right? I can say now this is playing. It'll be equal, or I can say something like this. Let's gonna flip the value of this, right? Gonna flip the value. So this is what I want you, right? For you to now call the handle key up, right? This is what I want. This is what I want React does when it mounts the component, right? So to register this, so I can detect that state, right? And when that happens, I can update the player, right? In other words, something. And also, when when this component amount, right? I want to provide is a cleanup function, which is say, hey, I want to get rid of all of this global state. So they register that. So let the browsers to remove this reference and have and free up the space. Say window dot add remove event listener, okay? Which is key up. Remove event listener. The type and the listener, all right? Yep. The key up and the listener, or the function handle handle key up, right? So this is it. This is it. So what happened here is that I need to return this as a function, right? Return this. So this will trigger is every time there is a re-rendering here. So in other words, it's going to call this function. The function is going to register these components, all right? And when there is an state update, it's going to now remove that event listener and create a new one. So this process is something that is doing over and over and over anytime the component is updated. So if I go here and then hit the spacebar, oh my god. Okay. Now remove event listener. Cannot read property of reading plane. And it's like this. Okay. Of plane. Cannot read property of null reading plane. Reading plane. Reading plane. Oh, what? Oh, okay. That's interesting because it's telling me you didn't do anything with the audio ref here. You know? Mhm. So the component itself. Okay. So it say that at that moment I do not have any reference of the elements there. That's very interesting. That's very interesting. So I'll need is not only to update the plane, all right, but I also need to update is the audio dot the audio ref dot current dot play. And here starting to see something like this, right? You can say, hey, if playing is whatever playing is, all right, whatever play it is, value here, I do want to do this, right? Exactly. So what I'm doing here is this. So if the code space, if the keyboard, if it is a space bar key, if it is a space key, then I want to ask, hey, if the playing is a falsy value, right? I was gonna go with this, right? If it's not, audio ref dot current. It's gonna pause. Okay. It's gonna pause here, right? And in any case, I just want to update the state properly, right? Say is playing, but flip the value, right? So now, if I hit here, that's interesting. Now if I reload this, If I click here, then I hit space, and it works. If I hit space here again, it works. No. So as you can see here is that, okay, this actually works. However, we are now is updating is this. So we are now interacting with two states here that live outside of. We need to synchronize is two things here. We need to synchronize is UI, and we need to synchronize is the player here, right? So this is what, and again, is doing this over and over and over and over. There is a state update, right? So you're telling the browser, hey, register this and register this function again, and so on and so forth, all right? Or you just can say is, please register this thing once, all right? Yeah, register these things once. I can do this, for example, like this, and this will work. Or I can say, hey, please register these things once, but it's telling me that, hey, I have a reference to an state, so you need to give it to me as a custom hook so I can keep track of that. And you might say, hey, sure, why not? It's playing, right? And that will work as expected, right? And that will work as expected, right? But here's the thing, and as you're starting to add more and more and more dependencies to these particular hooks, you might enter into another situations here, right? Where you say, that's interesting, but again, we have now, so this is a place where we are actually doing two stuff here, right? So this function actually is doing two stuff, which is updating the reference and then the updating that kind of stuff. This might be something that you want, at least initially, but if you're going to now separate concern, which is a very powerful concept from software engineering, you might want to wrap now is the state update in one useEffect, and the and updating the audio reference in another state. So how can we do that, right? And this might say, hey, you are going against the rules of React, and how dare you to do that, because this is not what React is for. But again, I'm writing this stuff because this is what first Josh Cormua mentioned, and he described this as he described this as part of this as part of the way of how you can organize your code in a way that is easy to read and to maintain. So what you can do is to say, hey, let me do is this, right? So anytime that is playing change, all right, I want to do one single thing, all right? In this case, okay. So I want to do is one single thing, right? So anytime that this change, I want to do one specific stuff, right? And here is when I want to register this, okay? So why this is useful? So if you reload this, okay. You're gonna hit the pause, you're gonna hit the play. Okay. Okay. You can reload this. Right. The behaviors remains the same, but what you did is just to separate the concerns about this. That's what we did here. It's just to separate the concern to say, hey, when this state change, I want you to do this one single thing. And when it changes again, I want you to do this one single step. Let's take a look at what now Josh Coleman mentioned about it.
So initially, I had planned for this challenge to be an exercise because I thought it would be this straightforward way to practice the ideas we've been talking about. But as I was actually solving this problem, I realized that there's a surprising amount of complexity to it. And actually, it's a great chance for me to share a couple of things I've wanted to talk about. One of them is a neat little trick to make sure that two different things stay in sync, and the other is an
exactly two different things stay sync. All right.
escape hatch we can use to access a stale state variable without changing the dependency array. To explain what's going on here, I've started to solve this problem using the structure that we've seen a few times now, where I have an effect. It doesn't have any dependencies, which means it only runs on mount, and when it runs, I add this long-running process, right? I subscribe to keydown events with add event listener, and my cleanup function undoes that work, unsubscribing from that event. The callback function checks to see if the key that the user pressed was the spacebar, and if so, I want to either start or stop playing the song. And this is where things get tricky, like how do I start or stop playing the song? Well, we can sort of cheat and look at what we did last time, right? I have this button on click and it does work. It starts playing the song when I click the button. But the tricky thing here is that I'm actually doing two separate things, right? One of them is that I'm changing the state variable. I'm flipping it from true to false or from false to true, but I also have to update the audio tag itself. And essentially, the realization here is that there are two separate pieces of state that I need to manage. One of them is my React state that I change with the setIsPlaying function, and the other is the internal audio state, right? Inside this audio tag, there is some sort of low-level state that controls whether or not I'm currently hearing the song or not. I need to do both of these things whenever I toggle the song's playing state. And so I could copy all of this code and paste it in over here.
Yep.
I don't love doing that idea, right? It doesn't feel very clean to me. I could create a function, maybe toggle playing, put this work in the function, and then call this function in both of those places. That would be better, but it does introduce sort of a weird thing with dependencies that we're going to talk more about when we talk about useMemo and useCallback. And it also doesn't really feel super safe to me, right? This function then becomes the only way to safely change this state, and other developers or myself in the future might not realize that. Like, I can easily imagine coming to this component, not paying a ton of attention, and wanting to implement some other way to start or stop the song, and calling setIsPlaying, and then we'd wind up in this bewildering situation where isPlaying is true, but we don't hear the song, and so like the UI is updating, but we don't hear the sound, and maybe we think there's something wrong with our speakers. I really don't want to go down that road. Like, ideally, I want this to be my source of truth, and I don't want to have to think about the audio stuff at all. Well, there is a way we can do that, and we're going to do it by adding another useEffect hook. The idea with this hook is that it's going to be responsible for keeping the internal audio state in sync with this state variable. And so the first thing I'm going to do is I'm going to add a dependency array, and it's going to include the isPlaying state variable so that this effect runs whenever that variable changes. And I'm going to check if isPlaying, so if we just flip this value to a truthy value, I'm going to call audioref.current.play. Otherwise, if it flipped to a falsy value, I'm going to call audioref.current.pause. This is going to be the one place where I manage this connection, making sure to keep them perfectly in sync. And so when I actually want to trigger that value, right, to start or stop playing, all I have to do is call setIsPlaying with the value I want. The component will re-render.
The component will re-render, exactly, because this is exactly what the usability. Yeah, this is what is great with this particular approach. You have now two places. You have now a way. You have now a way to synchronize you have implemented a way to synchronize. Uh, you have implementing a way to synchronize one state uh, from different sources, right? Or how to synchronize is one state from multiple sources, which is something that he mentioned. That
will now be the opposite value that it was, and I will trigger one of these two methods. Now, I should say this is a somewhat controversial approach. There are those who think it's actually better to use a shared function, right? The toggle playing idea I shared earlier. But in my opinion, this is a much more foolproof way to go about it. That way I never have to think about the audio state. I can focus purely on my single source of truth, the isPlaying state variable. With this done, I can now grab the same stateSetter function and I can call that inside my keydown event listener. Now when I do this, I get a lint warning about a missing dependency, which makes sense. I'm trying to access the isPlaying state variable, despite not putting it in the dependency array. But just for fun, I think it's a good thought experiment. If I dismiss the warning, what are the problems, if any, that I'll actually have? Like if I try to use the spacebar shortcut now, will I get an error? Will it kind of work in some ways but not others? Will it work perfectly?
no,
and maybe the warning in this
useEffect will have is a stale reference. The user state will have now a stale reference of your state. That's what happened, and this is the point of this. When you're working with this callback state setter.
This case was a red herring. If you'd like, I'd encourage you to take a couple of minutes, pause the video, and think about it, right? Make a prediction about what you think will happen. To figure out if this works or not, I'm going to test it out. So I'll focus this window and press the spacebar key. And I do hear the song start. So far, so good. I press it again to pause it. Well, it's able to start the song, but it's not able to stop it. To explain what's going on here, I've created yet another graph that shows each of these renders over time. We see in the first render isPlaying is set to false. We then start our effect, which runs this long-running process. And every time I press the spacebar key, we're calling set isPlaying to not isPlaying. But the isPlaying state variable that we have is this one, right? We only have access to the data in the same snapshot. And so this effect can only ever read this value. And so every time I hit the spacebar key, I'm calling set isPlaying with not false, which is true, which explains why the first time I do that, it starts playing the song, which is good, that's what we want. But every subsequent time after that, I'm still calling set isPlaying with true. I'm not flipping between Boolean values because I only ever have access to this value. Now, if we go back to our code, there is a couple ways for us to fix this. The first one is the one that we've seen before, which is I can add this dependency to the array. With that, we see the red squiggle goes away and things work the way we would expect. But what does this actually do here? Like, why does this work? Well, I have yet another graph to help with that. I know it looks kind of chaotic. Don't worry though, it will make sense momentarily. Things in this one actually work pretty similarly at first. I have my first snapshot isPlaying is set to false. We test to the data, it's a constant label, and that performance liability in this case. But there are other additional update calling set isPlaying, and the parameter is the cleanup only runs when the cleanup function is called when this component unmounts. The difference is that I am no longer trying to read values from the snapshot. Instead, I'm plucking the freshest value possible from the component instance. These snapshots are like moments in time, right? All of the state variables will... Now, in terms of which of these approaches is better, which one should you use, honestly, in most cases, they both work equally well. There is a minor performance benefit to doing it this way because I'm not constantly adding and removing event listeners, but you know, in general, these costs are pretty negligible. So in general, I would say go with the approach that makes the most called isPlaying. X is whatever the awkward, like current isPlaying doesn't really read super cleanly, so maybe I'd go current value. Either of those are fine. I just like the disambiguation between what's going on within this callback function and the actual state variable associated with whatever the name of the state variable is. I also sometimes will use current value if current X feels a little bit stay in sync.
But again, what he mentioned, and I want to wrap this up with this note.
And the other is an escape hatch. We get a chance for me to share a couple of things I've wanted to talk about. One of them is a neat little trick to make sure that two different things stay in sync.
Exactly. Two different things stay in sync. here. So that'll be all for this video. Take care. Bye bye.